Imagine you have a line of toy cars, and you want them arranged from smallest to biggest. Instead of moving them all at once, you play a simple game. Find the smallest car and put it in the first spot, then the next smallest in the second spot. Keep doing that until every car is in the right place. That's exactly how selection sort works. Now let's understand it with code, line by line. Selection sort. On every pass, we find the smallest remaining value and swap it to the front. Let's read the whole method first. We'll go one line at a time, slowly, then watch it actually run on a small array. First, n. That's just the length of the array, how many elements we have to sort. The outer loop. I walks from the front. Everything to the left of I is already sorted and locked in place. At the start of every pass, we assume the element at position I is the smallest. So min_img starts at I. The inner loop sends j across the rest of the array, from I plus 1 all the way to the end. For each j, we ask one simple question. Is this element smaller than the smallest we've seen so far? If it is, we remember where it lives by moving min_idx to j. Once the scan finishes, we swap. First, we store the value at I into a temporary variable, tmp. Then we copy the minimum into slot I and drop tmp into the minimum's old slot. That's the whole algorithm. Now let's run it. Pass 1. I is at index 0. We assume 5 is the smallest, so min_idx points at index 0. J starts at index 1. J is at index 1. Is 2 smaller than 5? Yes. So min_xd jumps to index 1. J moves to index 2. Is 4 smaller than 2? No. Min_idx stays. J moves to index 3. Is 6 smaller than 2? No. Keep going. J is at index 4. Is 1 smaller than 2? Yes. Min_idx jumps to index 4. Last one. J at index 5. Is 3 smaller than 1? No. The scan is done. 1 is the minimum. Now swap. 1 and 5 trade places. 1 is locked at the front and it will never move again. Pass 2. I is at index 1. We assume 2 is the smallest. J starts at index 2. J at index 2. 4 smaller than 2? No. J at index 3. 6 smaller than 2? No. J at index 4. 5 smaller than 2? No. J at index 5. 3 smaller than 2? No. 2 was the minimum from the start. Min_idx still equals I, so the swap does nothing. 2 is already in the right place. The code still runs the swap. It just swaps a cell with itself. Pass 3. I is at index 2. We assume 4 is the smallest. J starts at index 3. J at index 3. 6 smaller than 4? No. J at index 4. 5 smaller than 4? No. J at index 5. 3 smaller than 4? Yes. Min_idx moves to index 5. Swap. 3 and 4 trade places. 3 is now locked. Pass 4. I is at index 3. We assume 6 is the smallest. J starts at index 4. J at index 4. 5 smaller than 6? Yes. Min_idd moves to index 4. J at index 5. 4 smaller than 5? Yes. Min IDD jumps again to index 5. Swap. 4 and 6 trade places. 4 is locked. The sorted region grows by exactly 1 each pass. Last pass. I is at index 4. We assume 5 is the smallest. J starts at index 5. J at index 5. 6 smaller than 5? No. No update. Min Ix equals I, so no swap. 5 is in place and the very last element, 6, is automatically correct. Every element has settled into place. Selection sort always makes exactly n-1 passes. There is no early exit. So the time is always O of n squared, best, worst, and average. Space is O of 1, just 2 variables, and it is not stable by default. Here is the exact same logic in C++. The array comes in as a pointer with its length, but the loops and the swap are identical. And here it is in C. Same structure, same swap, only the syntax changes. The algorithm does not. If selection sort is clear now, please like and subscribe. Bubble sort is next.